Okay, so I've posted a few very fundamental videos, and at this point, people are gonna get bored, especially my viewers, of course. So this one is more complicated and more up to par to the abilities of my viewers. So well, part A is still very easy because it's part A, but then from B onwards, it's gonna get more complicated. So let's still do part A as well because we need that. So A1 is easy. We could do that in our sleep. The obvious fact is that we're gonna do by parts, and then this question is solved basically. And then, which means we have oh, that should be WX. Let's not get that wrong. And then putting in B, we get FB of from A to B GX dx, because dummy variable and property of WX. And WA is 0 because obvious reasons. I'm not going to explain that. So we get the first term. In second term, we just throw the fx out of the d of whatever. So we get this. And that's part A1 for you. Very simple. Well, it should be flipped, but I don't care. It's the same thing. Part A2 is also simple. So we're given theorem star and we want to prove whatever's up there. So obvious fact, we could use part A1 as well because we just proved it. And then we could now use theorem star here. We could use theorem star here and say this is W of A from A to B f prime of x dx. It should be C. Sorry about that. Where C belongs to this interval because the theorem star says so. So now we could have this part minus this bit is FB minus FA. And then WC is from A to C of this. So now we have F of B from C to B of this minus F of A from A to C of that. Oop, it should be GX. And that's it for part A2. Very simple as well. Part B is when things start to get harder. So, but then there's a very, very simple hint right there, which means we could do this in one go, I think. So obviously, oops, excuse me. This one, using part A2, we could get, just gonna verify something because I can't remember. Okay, cool. Is equal to f of b is negative 1 over f prime b from C to B of gx is that thing, negative f prime x cos fx dx minus, that should be a plus here, so that's a plus, negative f prime of a. Couldn't really write that in one line, so let's edit that. Plus negative 1 over f prime of a from A to C of this thing. dx, and absolute value, which means absolute value from a to b of cosine fx dx is equal to absolute value of 1 over f prime b of whatever. So now let's put things basically doing by parts, but easier. Let's do it this way. Okay. Oh, that should be a C, my bad. And now it is simple because we have 1 over f prime of b, and then that's just sine fb, and that should be a C, and then minus 1 over f prime of b sine of fc plus 1 over f prime of a sine of fc minus 1 over f prime of a sine of fa, absolute value. And here this is just triangle inequality, and we get less than equal to and then triangle inequality, and then, well, f prime of x is greater than or equal to m, so 1 over that means this is smaller, and then sine of x is always less than or equal to 1, so we have that is less than or equal to 4 over m. And that's it for part B. Quite tricky because we need to use triangle inequality. And then part C1, well, this one's a little bit more straightforward than part B. So obvious fact, we know that this is true, which implies this is true, which implies this is true. Wait, excuse me, that's the other way round. Sorry about the error there. And then this just implies the fact in part C1 because cosine is decreasing from 0 to 1, which means we could have that there, which means this is true. Okay, so this one is the easy part. Now it comes down to another part. So we know this, so we're going to use this to imply limit 0 is less than or equal to limit cos of xn, integrated as well, we'll do that in the next step. 1, which implies limit integrating 0 just gives 0, so I'm not going to do this. And then that's just from 0 to 1 of cos xn dx. Okay, so now we could have which means 0 is less than this limit, which is less than 1. And that just implies, I'm going to write it down on the next row, which implies exists. And that's part C1. Just a little bit of intuition and you'll get through it. C2, we want to show that that limit exists. And we already know that from 0 to 1 integrated of that function, and then take the limit, and that limit exists. So all we need to know is we need to find this integral from 1 to 2 pi of cosine of x and dx. And let's set so set fx equal to x to the power of n, which implies f prime of x is equal to nx n minus 1, which implies f prime prime of x is n minus 1 x n minus 2. And we all know that f prime x in the interval of 1 to 2 pi, I'm not going to write that there, from 1 to 2 pi, we all know that this is greater than 1, which is greater than 0, and f double prime of x, we all know x is from 1 to 2 pi, so that is obviously greater than or equal to 0, which means we could use the conditions in part B of the theorem, sorry. So we have this function is less than or equal to 4 over m, but that m value in part C2 is n, sorry, not 1. That is insane. So we could have 4 over n here, and then which implies limit of this function is equal to 0, and obviously without the absolute value function it's also 0. And now we need this from 0 to 2 pi. That one is just equal to 0 to 1 cosine of this plus this limit that we did just now. This one's 0, which means this is equal, oh, excuse me there. And this exists, so that also exists, so we could conclude the answer required. And that's it for this question. Very interesting.